Let's now move on to the idea of probability. These next several videos will be discussing various concepts of probability. It's extremely important that you understand the basic idea of what probability is, because most of what we will be doing the rest of the course is based in one way or another on a probability. So once again, let's look at the learning objectives, what we want to make sure we get out of these next several videos. First of all, we want to simulate simple experiments and compute empirical probabilities. So obviously we're going to have to also define what empirical probability is. We want to compute both theoretical and empirical probabilities, and we want to be able to apply the rules of probability to compute probabilities. Now there's a bunch of rules that we'll be going over. There are several of them, and we'll be doing individual videos on most of them and looking at how you apply them, what the names are, what they mean, and so forth. We want to be able to compute probability based on an odds. So we need to define what odds are, and compute odds based on probability. So this is the main idea that we need to get out of the next several videos. So let's start off with the idea of simulation. First of all, why would we be interested in simulation? Well, for one thing, it's much more efficient than actually running an experiment over and over and over again. Now, it's not always possible to simulate everything. There are extremely complicated, extremely technical simulators that are available to simulate many things. We will be simulating very simple experiments like tossing a coin. Relatively speaking, simulation is relatively expensive. It's not a lot more inexpensive, as example, letting a pilot actually crash a real airplane rather than working in a simulator. NASA has extremely complex simulators. Obviously, we won't be going to that extent, but it gives you the idea what I'm talking about here. Also, with simulation, it's easy to make minor changes and see what effect the changes have on the outcome. Okay, so let's start off with a simple example here. I want to simulate tossing two coins, and I'm going to use TCstats to do this. Here's the idea. You don't know the probability of observing a head on a single toss. Actually, I'm going to leave this as single. I'm going to do this both as single and two coins. So I'm going to actually do two simulations for you here in just a moment. A good way to get a reasonable estimate is to toss, say, a coin 1,000 times and check the results. Likewise, this would be for a single coin. Likewise, if I took two coins and tossed it 1,000 times, I could count up the number of heads and get a good idea what the probability of getting a heads in two coins. If I toss a single coin 1,000 times, obviously I can look at that and figure out reasonably, get a good idea of what the probability is of getting a head in a single coin toss. Now remember, the idea here is that you don't know, so you're trying to run an experiment to figure this thing out. Now, if you were to actually toss a coin 1,000 times, well, you may as well bring your lunch. It's going to take you some time. Instead, we can use some technology to simulate the process, and that's exactly what I'm going to do here. I'm going to use TCstats to set up a simulation for us. Now, here I am in TCstats, and this is a very blank window. This is like the first time you fire up TCstats, basically. There's no data sets, anything. And I'm going to tap on New to create a new data set. And right now you can see it's called Untitled. I don't care, I'm going to leave it untitled. It's not that big of a deal. Or we could tap on it and change it to coin toss or something like that if you wanted to. It's not that big of a deal. Now here, what I'm going to do in the column, and you can see down here, I'm going to tap Save real quick, and I get the Edit button in the lower right. See the Edit button right here? If I tap on Edit, that brings up that menu down below. And more importantly, when I tap on the name column, and I reach up here and tap right here on column, I get a bunch of options. And one of the options you can see is random data. So if I tap on random data, I'm going to tell it the lower bound is going to be 0 and the upper bound is going to be 1. What I'm doing is I'm coding a head as a 1 and a 0 as a tail. Now, when we generate random numbers, you have a couple of options here. One of them is to generate random numbers with replacement and without. Typically, when you're sampling from something, from a population, we would sample without. But here, I want to be able to replace. In other words, if it picks a 1, I want to be able to pick a 1 again. I want it to have the ability to choose more than one 1. So I'm going to tap this and insert row starting at row 1 and ending at row 1000. So in other words, it's going to generate 1000 random numbers. And then tap done. And you can see I have a bunch of 1s and 0s. Now I will save it by tapping save, and now tap on the column, and I'm going to make sure that it's ratio. That way I can actually do something with it. Even though it's really a label, heads and tails, I want it to be ratio so that I can produce some stuff with it. Sometimes we'll lie to TCstats about the actual measurement scale so that we can produce one thing or another. And actually, one of the things I'm going to do is simply produce a frequency distribution. So I really could just simply say, all right, let's just make this ordinal instead, because that would still work. So this is one coin. So what I'm going to do now is tap on coin toss, because up here, this is the name of my data set. And then under graphs, I'll select frequency distribution, select this column, because I never renamed it. And see the order here? If I tap on the order, because it's ordinal, it knows that it's expecting an order. 0 first and then 1, that's exactly what I want. And you can see here that I have 48.9% tails, 51.1% heads, because tails and heads. So absent any other information, if I knew nothing about the probability of flipping a coin, I would guess that I would have 51.1% heads and 48.9% tails. So remember, this is experimental. If I redo this again, I'm going to get different numbers. Likewise, I could quickly go back and create a histogram. And here I'm going to tell it to use the lowest value. Well, actually, I'll just type in. Well, actually, take that back. Here, it's recognizing the fact that this is ordinal data. So I have the ability to change the order here by simply grabbing these little handles here. And when I hit graph, there's my bar graph. It's not very pretty because it's nice and fat, but you can see here that essentially it looks like they're almost even. There's my 48.9%, my 51.1%, and my raw counts. Okay, so I'm going to go back now. That was simulating one coin toss. So I'm going to tap the edit button, and I'm going to tap column, and I'm going to change this name. I'm going to make this say first, simply because it's the first coin. And then you notice here it says append column. So I'm going to add another column to it. I'll tap on that column, and I'm going to call this second to represent my second toss. Tap random data, and it's going to remember what I did last time. So I will hit done, and then I have a bunch of random numbers there again. Save it. Now I really need to change this to at least interval. So I'm going to make this ratio. Interval would have worked. The point being is I'm about to add these together. Because if this is my first coin and this is my second coin, that means that this toss, number one, ended up in 2 tails. So I needed to add these up to say 0 over here so I know it's 2 tails. Here I have a head and a tail. So when I add these, I'll get a 1. That means in 2 tosses, I ended up with 1 head. So once again, I will go to Edit. I'll tap on First, and then you see down here column arithmetic. Now, column arithmetic would not be, would be grayed out if I did not have ratio data here, or interval. I have to have something I can actually add. So I tap column arithmetic. I'm going to add, I'm on the first, so I'm going to add to it the second. And then store results in. It defaults to saying first plus second. But I'm going to change this to simply say heads, because that's what it is, the number of heads. Then I'll tap on perform operation. And over here I have, you can see the addition. 0, 1, 1. Here there were 2 heads. So this is actually the number of heads now in 2 tosses. So I'll save it, and I'll set the measurement scale. Let's go ahead and leave it as ordinal. And then do a frequency distribution of the number of heads. Check out my order, 0, 1s, and 2s, that's what I want. And then there they are. So my best estimate for the probability of getting no heads and costing 2 coins is approximately 21.5%. My best estimate for getting 1 head out of 2 coins is 53.5%, and my best estimate for getting both heads is 24.9%. Again, these are just estimates because it's empirical. Well, we'll talk about what empirical means in a few minutes, but it's just the best estimate as a result of actually simulating a coin toss. Now, in reality, and we can show later, that this is actually 50%, this is 25%, and this is 25%. And theoretically, that's what should happen. But based on 1,000, that's what we ended up with. If I were to increase this to like 2,000 or 3,000, these numbers would get closer and closer and closer to what it theoretically should be. So that's a quick discussion and demonstration of simulation, simple simulation using TCstats. We can actually do much more complicated stuff with it.